OpenTelemetry is one of those technologies that you know you have to learn as soon as possible. But every time you're trying to learn all by yourself, you end up wondering, why does it have to be that complicated? If this is you, don't worry. A lot of people, myself included, finds OpenTelemetry a complicated technology. But here's the bright part. In this video, I'm going to explain where this complexity comes from and provide you a path to implement observability using OpenTelemetry and how to instrument your microservices using Java. And guess what? It's going to be everything hands-on. Hello there and welcome. My name is Ricardo Ferreira and I'm a developer advocate here with AWS. If this is your first time here on the channel, I would like to personally welcome you in this platform that we've created to have this type of conversations with you about technologies, open source projects, and design patterns that you can use to build cloud-native applications. Technologies such as OpenTelemetry, which is arguably the reason why you're here today. So let me give you an overview about what this series is going to be about. This series is going to be broken down into 7 parts. Throughout all the series, we're going to use an existing code that contains the implementation of a microservice written in Java. However, this implementation has no instrumentation whatsoever, and we're going to build it together. We're going to start by using something called the OpenTelemetry agent for Java that is going to allow the JVM to produce telemetry data such as traces and metrics automatically without you writing a single line of code. Then I'm going to show you how to implement the OpenTelemetry collector. This is a key component of the OpenTelemetry architecture that allows you to buffer, process, and send the generated telemetry data to compatible observability backends. I'm going to show you how to configure this OpenTelemetry collector to send the generated traces, for example, to a backend called Grafana Temple, where we're going to be able to visualize those traces. Then we're going to go back to the instrumentation process, but now leveraging the OpenTelemetry SDK for Java, where I'm going to show you how to code your instrumentation to create your own custom traces, and you're going to be able to see those in the Grafana Temple backend. I'm going to also show you using the OpenTelemetry SDK for Java to create your own metrics. So you're going to be able to not only create, but control how those metrics are going to be updated, and you're going to see this in the compatible observability backend in the next section, which is going to be how to configure the OpenTelemetry collector to send those metrics to Prometheus. Lastly, I'm going to show you how you can configure the OpenTelemetry collector to switch the observability backend from Grafana Temple to AWS X-Ray and from Prometheus to Amazon CloudWatch without necessarily touching in a single line of the instrumentation code that you have built in the microservices implementation. Now that you know what to expect from the series, please know that you can consume it in 2 different ways. The first one is walking through each part of the series individually, and then you're going to be exposed to all different use cases that you may encounter while we implement observability in your own projects. Or if you are interested in one particular problem, such as, for example, how to implement custom metrics using the OpenTelemetry SDK for Java, you can jump straight to that part that is going to focus on teach you only that part. Regardless of what strategy you're going to take, want to make sure that you're going to stay with you through the entire journey. Let's get to it. As I mentioned before, the whole code of the microservice is already available on GitHub, and you can find that code by using this repository called Instrumenting Java Applications using OpenTelemetry. So the process that we're going to do now is basically clone this repository so you can have a copy of the code available locally. However, instead of cloning the actual main branch, which is the branch that contains the whole code implementation, we're going to use a specific branch called Build on AWS Tutorial that is incomplete on purpose. So everything related to the microservice code is there, but there is no instrumentation code whatsoever. So nothing related to OpenTelemetry will be available for you to leverage because we're going to build this together throughout this series. So what we're going to do now is to clone this repository, but focusing on this specific branch called build on AWS tutorial. So go ahead and open a terminal so we can start the cloning process. To clone that repository, we're going to use the git command line interface. So go ahead and type git clone and provide the URL of the repository that you intend to clone. But like I mentioned before, we're going to use this specific branch called build on AWS tutorial. So once you have a local copy of that branch, we can start investigating the structure of the code and spin up the observability backend for development purposes to make sure that everything will be available for us to start the instrumentation process. So you are not required to. I'm going to use here in this tutorial and series of videos the Visual Studio Code, because just to make sure you can visually see all the project structure in an easy way, but you can obviously use the terminal if you are comfortable with it, although I probably wouldn't recommend this because it's too much effort, but it's up to you, right? So right now I'm going to open the code in my Visual Studio Code IDE so we can start investigating the structure of the project. So let me start by explaining the project structure that we have here. So as you can see, this is a simple Java project that has been implemented using Maven and Spring Boot. So because I've used Maven, you're going to see that this pom.xml file here is going to be the file that we're going to use to add or remove dependencies required to compile and execute the project. So in future parts, you're going to see that we're going to add the dependencies for the OpenTelemetry project exactly on this file. Also, you're going to see that the actual implementation of the microservice can be found in this Java class called Hello App Controller. So this is the class that contains the actual implementation of the microservice. And there's also this script called run microservice.sh that we're going to execute the script throughout the entire series. So be sure to become familiar with it, because we're going to not only execute the script several times, but also change it, because here's the place where we're going to actually introduce the behavior of the instrumentation and some of the components of the OpenTelemetry project. So as a matter of fact, you can go ahead and execute this script for the first time. So let me run microservice, and when that happens, you're going to see that two things are going to happen. The first one, a Maven build is going to be executed. So to generate a fresh version of the jar file, this is important because we're going to keep changing the code several times. So always running with a fresh copy of the new implementation is important. And also, you're going to effectively execute the Spring Boot microservice. So whenever you see this message here called started hello app, it means that the microservice is up and running. So, and actually we can double check this by sending a message to the REST API endpoint exposed by this microservice. So you can do this by curl -x, which is get, and then the endpoint is going to be exposed here in HTTP localhost. The port is 80808080, and the endpoint is /hello. So when you do this, you're going to simply see that it's respond with the hello world message. So simple hello world, nothing fancy, but the important part is that this microservice is going to be our playground for introducing the instrumentation process using the OpenTelemetry technology. Now that we've seen that the microservice is actually up and running, you can actually stop the execution right now. We can go ahead and check if the observability backend that we're going to use for development purposes, namely, we're going to use Grafana for visualization, Prometheus for storing and visualizing the metrics, and Grafana Temple for the tracing technology. So all these technologies are available for you to use, because this project also makes available for you this Docker Compose YAML file here. And this Docker Compose YAML file, you're going to see that there is a definition of a Grafana Temple service, the Prometheus service, and obviously you're going to see the Grafana visualization too. So in order for you to play with this, you're going to need to have Docker install it on your machine, and also Docker Compose to execute this those services. So I'm going to actually execute them right now to make sure that everything is available for us to use. So Docker Compose up. I'm going to use -d to inform Docker Compose that I want to kind of keep them running in the background. if this is the first time that you are going to execute this script, be mindful that you're going to actually pull all the Docker images from the repository. So this might take a while depending on your network speed and depending on a lot of other factors. So once this completes, the actual containers will be up and running. So just keep that in mind because it might take a while. So I'm going to actually give a pause right now because I know that, at least in my case, it's going to take at least a couple minutes. So see you in a second. And I'm back. So it seems that all the containers are now up and running. So Grafana Temple, Prometheus, and Grafana, as you can see here. So to make sure that this is actually true, go to your browser and we're going to actually access the endpoints to see if the information from the services can be retrieved. So the first endpoint that you should take a look is localhost port 3200/status. So this is going to be the information from Grafana Temple. So as you can see here, it seems to be up and running properly. And then also issue a request for localhost port 9090 and then /status. So this is going to be the information from the Prometheus server. So also it seems to be up and running. And then go to localhost port 3000. And only by doing that, you should be able to see the main page of Grafana. So you also should be able to access Grafana unauthenticated. So no credentials are required. One important aspect that we should discuss before we wrap up this is that in Grafana, make sure to verify if the data sources are configured there. So what are data sources? So all the telemetry data that we're going to produce using OpenTelemetry, traces, for example, will end up on Grafana Temple. And then for Grafana to be able to visualize them, a data sources point to the Grafana Temple has to be created. And it is going to be created automatically for you using the Docker Compose file. So you don't have to do anything. You just have to verify if the data source is there. Same goes to Prometheus. So all the metrics that we're going to produce using OpenTelemetry will end up being stored on Prometheus. And then there has to be a data source that queries Prometheus to visualize those metrics. So what you actually need to do, pragmatically speaking, is to go to this menu here that says Explore and then click on it. And you have to make sure that in this drop-down box here on the top, there is the options Prometheus and Temple. If they're showing up there, it means that the data sources has been properly configured and they are pointing to the specific backend services. So there you have it. Everything that we need to start our instrumentation process is in place. So in the next part of this series, we're going to start the instrumentation process of the microservice using the OpenTelemetry agent. So I'm looking forward to see you there as soon as possible.
Hey there! Thanks for checking out this video. Remember to give it a like and share with your community. Then hit subscribe and the bell for all the latest content that will help you build on AWS.